uh, uh, compute the entire values using some optimal solution and construct this arrays or tables and just store all the computed values inside this. So these are the different steps where you will apply this dynamic programming. So next, when creating some optimal substructure, so that is nothing but you are combining the result. We have to see three different things. That is nothing but your intermediate node, destination node, and minimum cost node. So you will always calculate the minimum cost between the source node and the destination. Okay, so what things you have to do to make the sub problem as optimal is you have to always find the minimum path from the source to the destination. For that, in dynamic programming, we'll just use that intermediate node along with the source node and the destination node. So this is one of the thing, or you can solve using overlapping subproblem. So one good example for this is Fibonacci series, and there are also, as I said, we have top-down approaches and bottom-up approaches. Usually, top-down approach is nothing but memorization. So this is the final solution, which recursively breaks it down into smaller subproblems to avoid the redundancy calculation. Okay, it also stores the solved subproblems in the memorization table. So this is used in the top-down approach. Okay, so in the top-down approach, usually it starts with the final solution and recursively breaks it into smaller subproblems. So these are stored in the table format generally. So for this redundant calculation, and it also is stored in large number and it can be reused. Actually, when you change the problem, you can use this a table or array address, the same table or array address. So it is generally helps in reusing it. So these are the things you can do with the bottom down approaches. When you come up to the bottom up approaches, it is as I said here also, there is a tabulation, but the tables are filled in the bottom up manner. Okay, not top down manner. So it is filled by the top down manner. The sub problems is small, but the optimal solution computed should also be very smaller. Okay, there will be a solution for all the sub problems. The computation speed also should be very smaller. Okay. Next, this dynamic algorithm has uh, uses some other common algorithm along with the dynamic algorithms. Yes, so this is one example for longest common subsequence. So there are many other algorithms for common algorithms like longest common subsequence, shortest path in the graph, or a knapsack problem, or a Neves algorithm, matrix chain multiplication, Fibonacci series. So these are some of the common algorithms that uses the dynamic programming. So in the Neves algorithms, here you can see the subsequence of X, where you can check the subsequence of Y solutions. So you can have the integrity time of n power 2m. So where you have subsequent problem divisions of Y in the entire subsequence of X. So these are some of the problems you can solve for the longest common subsequence. So coming to the recursive is nothing but using the same structure of program n number of times where the user needs. So here you can see where you can see the series and solve the problem. The range, if it is equal to x and y, that is your sub problems, is similar to the entire problem, you will have one solution. If your sub problem is not equal to, you will be having another one solution. Okay, so this is just a recursive solution tree. So this is how you store in the table. Either you can use a top-down approach or a bottom-up approach in storing the values. Okay, so this is the computing the length of LCS algorithm. So this is the pseudocode for computing LCS. So here you store both the length of x and y in another variable m and n, and you also uh, see this range where if it is initially 0, your table you will make it as empty. If it is x, the subsolutions of x is equal to subsolutions of y. Here I am given it as alpha and beta. If it is equal to, here you will be storing with that series of values. Then if it is not equal to, then you will be able to place the maximum value available in the prefix. Okay. And there is also one more algorithm for constructing the logical sequence, longest common subsequence. So next is we also have many advantages in using the dynamic programming. So advantages like it can avoid recomputing the same sub problems multiple times and leads to the significant time save. Okay, so it generally saves the time. It avoids recomputing again and again. So this is one of the good advantage of dynamic programming, and it also ensures the optimal solution that is found considerable in all possible combinations. So it is going to give it in the all possible combinations. So we'll be working it in all sub solutions. Okay, so that you will get a variety of solutions, and you can choose the best optimal solution out of that. And next is when you're breaking the complex problems into smaller one, it is more manageable. Okay, so these are the application. The main thing is it is going to optimize, and it is also applied in many operational research, and it is used in the computer science for longest common sequence. It is used for editing a string or matching a string. Example. So if we all know about this binary search tree. We used to find the depth, the height of the tree, and what is the lowest cost for reaching the uh, from source to destination. So we will calculate the depth by taking the sub problems and calculating depth at each node level, right from the um, source node to the destination, and then we will calculate the probabilities among them. So each key node will have different probabilities. So which is the minimum cost is calculated using the probability of appearance of the node in the tree. So these all things are basic algorithm how you calculate the breadth first search. So finally, you will find the optimal solution with who is producing the minimum cost. Okay. So the recursive solution is nothing but you are going to repeat the uh, solved sub problems again and again. So that is nothing but your recursive solution. So this is a pseudocode I have given for the recursive solution. Okay, it's the main elements of the dynamic programming is nothing but your optimal substructure and overlapping subproblems. As I said in the advantages, what are the things like optimization and operational search. So here also the main elements of the dynamic program is you're creating an optimal substructure and you're going to overlap those subproblems. Okay, so optimal substructure is nothing but it is going to show the solution to the problem, and it also consists of making a choice which leaves one or more subproblems to solve by itself. Suppose that you are given the last chance that leads to an optimal solution. It is given that you can determine a subproblem and how to characterize the result. Either you can use the top-down or bottom-up approach. And this also shows the solution of the subproblem problem for the optimal solutions, and it must be them each subproblem must solve that there must be an optimal solution for them. Okay, so each solution when you find you will do the cut and paste in the table after calculating every solution. So you need to ensure that a wide range of choices has to be present between the subproblems, and you have to overlap them. So this optimal substructure usually varies across a different domain. So either you have to make some problem or choices. So, but you have to keep on running with time dependent values. So some subproblems do not take time depend. They are not time dependency. So each subproblem can take different time solution. But when you make choices, when some sub problems, it depends on the time. So the solutions may vary, and you may not sometime find the perfect optimal solution while you are using this running time dependency. So this dynamic programming is also uses the optimal substructure from bottom up. So first it finds the optimal solution, as I said. Next it uses the optimal solution. It is found out in the problem or matching to that problem. Okay, substructure is nothing but it will apply all the sub solutions to the optimized problem so that it can find the shortest path, not the longest simple path. The difference between this is shortest path is it has to have the minimum cost between the source node to the destination, but the longest simple path is where it will not have any graph or unweighted nodes. So why we have to use this is shortest path is always an independent subproblem. So solution to subproblem does not affect any other subproblems of the problem. So solution of one problem should not affect the other to find the optimal solutions. So as I said, divide and conquer and recursive algorithm is a very good example for this overlapping subproblem. So it can be solved in the same way, and the subproblems are more smaller when compared to the other examples in this. So this is about the dynamic programming approach. So coming to the second approach, that is nothing but your greedy algorithm. So why we are using this greedy algorithm for your computational approaches? It is it is not, greedy algorithm is not considered as a global optimal choice. Okay, so it is always considered to make the local optimal choices, because to find out the optimal solutions in the local level, we use greedy algorithm, whereas the dynamic programming we use for the global optimal solution, where you have some overlapping of the substructures there. So that is the difference. So generally, if you come under the greedy algorithm, so as I said, it is a class of algorithm which works for the local optimal choices at each step, and sometimes it also find some global solutions. So in this algorithm, the decisions are based on the information only. Okay, so they are not taking any data value or any value from the tree. So it is based on the information of the current moment. So what from the current source of node or current subproblem. So always it gathers the information from that. So the key idea is to select the best possible choice at every step, not to the destination or to the source level. So every step, the choice has to be best. So it keeps on updating its information at traversing each node. So we also understand the greedy uh, approach as a type of one of the optimization algorithm. So it makes some optimal choice at each steps to give the global optimum solution. So what is the principle to take this best solution is you have to consider the long-term sequences. Okay. Um, Long-term sequences. So what are the long-term sequences is first, before applying this, we have to define the problem, identify the greedy choice, make the greedy choice, and then repeat it. Okay. So here I have given one small selection problem with certain set of inputs and outputs. Before applying this inputs and outputs, we have to see all these four steps. That is nothing but to define the problem. We have to clearly state the problem to be solved and the objective to be optimized. Then we have to identify the greedy choice. We have to determine whether it is the local optimum at each step, or only at the current state, or we can proceed till the or we can proceed or update it till the entire distant state. So finally, for making the greedy choice, we select the greedy choice and update the current state for every state. Suppose here, if I am taking the start time of the activity of I and finish time of the I, it's not that I'm going to update my greedy choice at the point of S1 and F1. Okay, so each state of the activity, I will be keep on updating my greedy choice so that it can achieve the global optimization. So coming to this optimal substructure, we have different activities which ranges are sorted by at different finishing times. That is, it can be F1, F2, and till Fn. So it goes on till Fn. So we are going to make the greedy choice at each stage to find out the global optimization. And also, when you compare this algorithm with some fractional knapsack or registrar algorithm or Kruskal's algorithm, so there is a small difference, okay, in the optimization of this value. So in this optimization value, you are just updating the greedy choice, but usually in the knapsack problem or register problem, you will be having some capacity where you can where you have the source vertex, whether you have graph inside them, or whether you have some destination vertex. So all these things are not present in this. When you compare it with the Kruskal algorithm, you usually in Kruskal algorithm we'll find the minimum spanning tree of a weighted graph. Okay, and when you're using Huffman code, you used to find the shorter codes, which are keep on being used, or which are more frequent symbols. So those things are different from these 3D algorithms. So here also, you know how we use the recursive solution for the dynamic programming. Same way, you can use the recursive solution for the 3D algorithm. So you'll have the set of sub problems when you start it, when you finish it, and at each activity you take, the sub problem is not equal to infinity, and when it is equal to infinity. So this recursive solution is applied until you get a perfect optimal solution, which can be applied either locally or globally according to the problem statement given. So, greedy choice property, there is something called greedy choice property. So, this is nothing but an optimal solution to the subproblem of SINJ. Here, INJ are the starting nodes and the distant nodes. So, here the activity and the smallest finish time in the set S of IJ is given to each subproblems to calculate the greedy choice property. So this can be proved easily. There are also some other optimal solutions of S that can be included in alpha 1. So this greedy choice of the subproblem can be evaluated or upgraded. So you can solve the problem with the results of the different subproblem by storing it and analyzing it. And also you can combine this greedy solution to find out which has been found out in the each subproblem, and you can combine this to calculate the optimal solution. So this is just an algorithm which I have taken from the reference book. So this algorithm you will be teaching for the greedy choice property. So there are some steps where you can make some optimization. So you have to cast all the optimization problems as one in which we can make a choice either in the left or with the sub problem to solve it. So there is always an optimal solution that is has to be taken and makes the greedy choice safe in always. Show the greedy choice in the optimal solution to the sub problem is an optimal solution to the problem. So whatever greedy choice you are taking and finding the optimal solution to the sub problem will act as an optimal solution to the entire problem. So you can solve the greedy choice from top to down, where the bottom up approach is not available in the greedy choice. So there are some pre-processing inputs also given into your greedy orbit. So these are the two elements. There we saw some overlapping and substructure. Here we are having two components. For dynamic algorithm, we have two components. What is that? That is nothing but your optimal substructure, and there also you have optimal overlapping. But here we are having the greedy choice property and optimal substructure. Though the elements are different and the way of application is different, still greedy algorithm has its own advantages when compared to the other algorithms. So it can assign the tasks or to the resources without the waiting time or with a minimum waiting time when compared to the dynamic programming. So it has given the maximum efficiency when compared to the dynamic programming and some other approaches. So it also selects valuable items to fit into the knapsack, and it gives a limited capacity. but also with this limited capacity, it shows the maximum efficiency. And it can also be used in dividing an image into a regions or similar characteristics. It also reduces size of the data by removing the redundant information. Actually, dynamic algorithm plays a heavy role for reducing the size. Okay, reducing the size by its data. For this application, the best approach is the dynamic approach where you can use. But still, we still have some limitations for using this dynamic programming. Like it is always not that best possible solution is found. Sometimes we have different order of outcomes or significantly impacts in the other activity when one activity time stream updates the wrong resource. So that time the total output becomes wrong. So this limitations is there. Though it always focuses on the local optimization, but it doesn't gives a very much better solution when you put it into the global optimization problems. So, but it works good only at the level of local optimization techniques. So this greedy algorithms cannot be applied to all the problems. Maybe you can find the optimal solution to the local algorithms or local optimization alone. Okay, so this is some example for. I have just given one small example for minimum span tree. Okay, so as I said, the Kruskal algorithm it finds a minimum spanning tree. First, I have just said uh, what is the minimum spanning tree, how it works. So it is going to find out the source vertex to the other vertex without forming a graph. So that is called as a minimum spanning tree. So why we are taking this Kruskal algorithm is Kruskal algorithm finds the minimum spanning tree with the weighted path. So that is why we choose this. So generally it starts, this algorithm starts with its own vertex, and it repeatedly merges two components like light edge and connects them. So light edge is nothing but the crossing the cut between them. It scans the edges monotonically and increase the order. So that is nothing but each edge is updated, and it monotonically increase the weight of each edge when you shift this component from the start vertex to the uh, destined vertex. So there is also some disjoint set structures to determine whether the edge connects a vertical or its different components. Again, I have given some algorithm from Prim's algorithms also. So these are some of the examples you can just add up. If you want, I can share the slide for your reference. You can use these problems while teaching the class. Next is finally the randomized algorithm. Okay, so as of now, we have discussed two algorithms. That is dynamic programming and grading approach. So the next final one is the randomized algorithm. So from the uh, name itself, we get that what is the randomized algorithm. So what is randomized algorithm? Whether in the randomized algorithm is used in the data structures for computation of desired outcomes, or it is just a use.
Madhu ma'am? Madhu ma'am, it is audible ma'am?
Yes, ma'am, it's audible, ma'am.
Okay, so I hope someone is disturbing right now, ma'am.
Yes, ma'am. Just 1 minute, ma'am. I'll clear it. Sir, am I audible now, ma'am? Is still there is any disturbance?
No, ma'am. No, ma'am.
Yes, ma'am. Some issues were there in staff room. Sorry for the inconvenience. So let's
Okay.
continue. Yeah, let's continue with this randomized algorithm. Yes, as we went through these two algorithms, where and all you have to apply. So similarly, we are just applying in the same way, whether you have to just improve the efficiency or you have to make some desired outcome with some computations. Yes. This randomized algorithms not only improves the efficiency here, it is also used for different types of computations like quick sort. So it has some purpose. Okay, it is going to solve some complex problem with a set of rules. Okay, so that is why we use this randomized algorithm. So one of the best example for this randomized algorithm is nothing but the quick sort algorithm. So it is also comes under the data structures as the other algorithms. Uh, so this data structure algorithms are nothing but the algorithm which is computed to achieve some desired output, right? So it also serves to improve its efficiency, like dynamic algorithmic approach and greedy algorithm approaches. So I don't have the exact efficiency whether it can beat up the greedy algorithm and dynamic approaches. Um, but it also gives some efficiency up to 90%. Um, by incorporating some random choices into the process or random algorithm is even gives some faster solution, because we know for which kind of sub problem what sort of algorithms or what sort of initial rules you have to apply. So when you randomly apply some algorithms, you will get the faster solution, but you may not get the better optimization. So for better optimization, you have to use only some deterministic algorithms where you can improve the efficiency, like randomized quicksort algorithm. So, so this is what what is the randomization algorithm is. The main motivation is you're not supposed to use a random algorithm for efficiency. You can use it for the producing the result faster, but you can for a better optimistic solutions you have to use the deterministic algorithm. So how a deterministic algorithm will look like, whether you will give the input, you will apply some algorithm, you will get the output. This is what happens in all the algorithm. uh, So here you are giving the running time are determined only by the functions as the input. So all the inputs are set to be given in the running time of the function. So this when such kind of algorithm is executed, it becomes the deterministic algorithm. So when you give some random bits, not that all the inputs are running at the uh, running time of the function. So when you give some random bits and get the random output, then it is called as the randomized algorithm. You don't prefix what the functions are. You don't prefix the value, what are the inputs are. So when you prefix all the things determined, that is called as a deterministic algorithm. I hope you will have the difference between what is a deterministic algorithm and what is a randomized algorithm. So for creating this randomized algorithm, so this is one example where you can find the approximate median to solve it. So how to select uh, set of inputs? It can be array, string, values, characters, anything. So this numbers should be computed with the set, predeterministic range or the functions. Then we can store it for the deterministic algorithm. But if you pick some set of a range which is random, then it comes under the randomized algorithm. So for random algorithm, you can have some random samples. So they have given log n elements sorting from A. Then you have to apply sorting algorithm. Then you have to repeat it till you calculate the median of the particular sample S. Okay, so there will be some running time. This running time will be long for a randomized algorithm when you compare to the deterministic algorithm. So this is just a code for the quicksort algorithm, where your when your sample size is greater than one, you have to pick an element and you have to set a pivot element and then concatenate the two sort it and concatenate it to form the quicksort. So randomized quicksort is you will just set the pivot value not as a center, but you will pick some random value of the sample and then you will apply it. You will apply the concatenation and finding the sorted element in that particular sample. So this is the difference between just a normal quicksort and the randomized quicksort. So there are also different randomized last because algorithm where output is always correct, but the running time is similar to the random variable. So for that, I have already said that example is a randomized quicksort. So Monte Carlo algorithm here we'll calculate the approximation medium uh, where we have to calculate the medium. After that, we will apply the quicksort. So this is called as a randomized Monte Carlo algorithm. Here, this running time is deterministic. For last Ligas, it is set to that running time is a random variable. Here, the running time is deterministic. So, what is the real motivation? Whether you have to cut down the problem into smaller one, or you have to make it more efficient, or you have to apply some deterministic algorithms to make it more efficient. So there are many motivations like this, but actually the random algorithm choose both. Is it also concentrates in making the problem simpler, and it also wants to increase the efficiency. So it uses the different blocks of code. Either it gives some random inputs to make the loop run faster, and for efficiency, it gives some deterministic functions that has to be included in the algorithm, where it improves the efficiency of this randomized algorithm. So this is how it is used. So some I have given some examples for the deterministic algorithms like heap sort and merge sort, and for the randomized last because algorithm, I'm using the randomized quicksort. Here in the randomized quicksort, almost it outperforms, like it is performing well and gives a better output for both heap sort and merge sort. So the probability of the running time of the quicksort exceeds twice in its expected time. Okay. So here they have given some endpoints to computed in the radius to calculate the radius of the circle. So whether here to find out the location, maybe this thing we will be using for wireless sensor networks also sometimes to calculate the radius, how what is the range of the nodes, and how to solve the time complexity, all this. So this can be applied in the application like wireless sensor network. So smallest enclosing circle. So look, finding the location. So here we cannot tell that I want to determine the solution or I want only the fast solution. Sometimes when there is a problem, we need a fast solution and also we need it to be correct. So in such kind of problem, we add both. That is both randomized algorithm and deterministic algorithm to facilitate the exact location of the problem. So it is too complex, but sometimes it is advisable to geometry. But randomized algorithm is too simple, but it must be taken care that it satisfies the efficiency. Next problem is minimum cut. Like you have to concentrate on the time complexity this time. So you have to also reduce the error and redundancy. And you should for this you can use the minimum spanning tree or unweighted. You have to calculate the minimum cost without the unweighted graph, all those things. Finally, the primality testing. So these are generally used for the encryptions. I think you have heard very famous algorithm for RSA and algebraic algorithms. So this algorithms gives a good time complexity for both wet deterministic algorithms and for the randomized algorithms. So RSA crypto systems is used in many applications for this primality testing. So uncertainty, whether uncertainty is caused by applying both the randomized algorithm and deterministic algorithms. Yes, uncertainty is caused because you don't know what are the inputs are, you don't know what is the efficient output. So there is uncertainty, but it can be applied where you need your result fast. And later with that result, you can check with the deterministic algorithm. So that is the real fact. Um, so they have just given some case study by the Microsoft at the of 2008 itself, when we run the CPU for 5 days. So what is the number of failures? Okay, there is at least one failure in 330 times. Even when you are applying the deterministic algorithm, the range is this much, like 1 is to 330. The same thing when you apply the randomistic algorithm, it will be keep on increasing. So you must also have some solutions to clear that and keep on updating regarding that. Um, so these are the three things I have. These are the three algorithms I have discussed. Why we have using this computational approach, and what is the overall thing where all the three algorithms can be used. Okay, whether it is dynamic programming or reading algorithm dynamic. So we use it for only the computation purpose, or to solve any other programming. Yes. So dynamic programming is not only for computational purpose, so it is also used for bit masking, digital DP, some over the subsets. So for all these things, 3D algorithms are used. So the next thing is uh, in the current research or research affairs, or in the current research space, this dynamic programming plays a major role in both the security side and or finding the location, or finding the nodes range. For everything, we are using this computational approach of all these three algorithms, such as dynamic programming, reading algorithm, and randomized approach. And one more thing where we have using this is we are using informing the some over the subsets. That is nothing but just overlapping some problems what we have seen in the dynamic programming. So this sum over subsets helps to uh, find out global solutions, where the updated energy is located in the network, all those things. So anyway, all these three algorithms are used in both, either in the finding the security range, or the range of location of all nodes in the wireless sensor networks. I hope many of the people who are doing research in uh, these areas has gone through all this programming approaches, or used one or two in them. Um, so I have just given some theory explanations, or limitations and advantages where you can use all these things. So I hope it could have been helpful to you. Uh, that's all I think it's from my side. Madam, can I end it?
Ma'am, any doubt clarification, sir? Ma'am, Madhumita, ma'am,
Yes, ma'am.
any doubt clarification?
Yes, ma'am. If they are opening up, I can.
The participants, any doubt clarification? Or shall we wind up the class? Thank you, ma'am. Thank you for the wonderful.
Okay, ma'am. Thank you, ma'am. Thank you for giving me opportunity.
Thank you, participants who have attended this event, and thank you for the joining on the time. And your feedback link will be sent to your register mail ID. And tomorrow also you can join in the same link. Thank you all.